We'll begin creating a civil cell by opening up a file, a 2D file from a seed. We'll create a new file and we'll set up a working area. We'll set the working area up as 1000 by 1000. Next we'll place the reference lines. These will be placed with horizontal geometry, line between points. Reference line represents the linear or the elements in our design file that our cells will be attaching to. So in this case, I'm setting up a basic T. The T intersection will represent the edge of pavement through road, which is the horizontal line, and the perpendicular element vertical is the secondary road center line. These are elements that we expect will be in our design file that our cell will place onto. So we'll start by setting up our center line for our civil cell. We'll use a single element partial and we'll set and use element symbology throughout. We'll also use what is called priority to help us in selecting the elements after their place. So we'll set the center line, which will have a 0 offset value, and we'll snap it, or we'll use our snaps, which will generate a rule to the intersection. So we'll set the intersection and we'll draw the center line back from the intersection a little further than what our curb return radiuses will be. So in this case, I'll set it somewhere around 60 feet. Next, we'll generate or create the edge of pavement. To do this, we'll use single offset entire element, and again, we'll use element symbology. With our element symbology set, we'll select the center line, and we'll set our offset to 12 feet. Again, these are civil ruled elements, so at any given time, either before or after the cell is placed, we can make modifications to these, either the length of the center line or the edge of pavement lines. Next, we'll create the arc between elements, or the curb returns. Notice we'll set back transitions and ahead transitions to curves, and we'll set the lengths to 0. This will allow us to, in fact, place a curve that at this time will look like a simple arc, but in fact can be adjusted to a multi-center curve at any given point before placing or after placing. So we'll just trim the back element on both of the edges of pavement. Remember, the horizontal element represents the through road edge of pavement, so we don't want to trim that. We also need a seam line, however, to finish off our cell. So again, we'll set our element symbology, and this time we'll use the single offset partial, select the edge of pavement, and again we'll use our intersection snaps to snap to the intersection between the curb return and the edge of pavement. As an option, we can also set a construction line that will allow us to back off the seam with our center line. This will give relief to our profile if they don't quite line up going across at this point. So we'll set our symbology. With our symbology set, we'll also set the classification. In this case, we'll use a construction class. And we'll use single offset entire element. We'll select the seam, and we'll set a 1 foot offset. We'll change our classification back to primary so we don't forget. And then we'll trim our center line to this element. So we'll use the microstation trim command, select the center line element, select the construction, and now you see we're trimmed back. Now we have all our horizontal elements in place. We're ready to begin our vertical design. Take note, we're in a 2D file with no 3D model as of yet. We'll begin our 3D design by using the vertical geometry profiled by constant elevation, and first we need to apply an elevation to our reference elements. Again, these represent edge of pavement and secondary road center line. We'll set an elevation of 10 feet. Any elevation will do. Immediately, we'll see a 3D model has been put in place. We can set up a 3D model view so we can watch as the cell builds. We'll just go in to our view attributes and we'll select default 3D. We'll also make a couple other changes. We'll change the clip front and clip back, and we'll change our settings to transparent with shadows. Notice we only see the 3D elements in the 3D view. At this time, that represents the edge of pavement and the centerline secondary road. Next, we're going to set the profile by vertical offset from element. We'll use this to set our primary element centerline profile. So we'll set the slope style to constant. We'll select the plan element, which is the cell centerline, and we'll set the reference element. We'll lock to start and lock to end our ranges. And we don't see it very easily, but if you look close, the element has been added. While we have this tool active, we'll also do the seam line. The seam line, though, will mimic or be offset from the edge of pavement of the through road. So again, we'll set a constant elevation, data point to select the seam line, and we'll select the referenced edge of pavement element, locking the start, locking the finish, setting the vertical offset to 0. And again, if we look closely, we can see the element is now in 3D. Next, we'll set the edge of pavement slopes. In this case, we'll use the profile slope from an element. We'll select the two edge of pavement elements, reset, and locate the referenced element, making sure we're only selecting the center line of our cell. We'll key in a slope value, in this case of -2%. This can be adjusted at any time prior to placing the cell or after placing the cell. With no vertical offset, we'll accept. Again, we'll see the elements appear in our 3D view. Next, we'll use the quick profile transition to put a parabolic profile onto our curb returns. We'll repeat for the opposite side. And now we're ready to build a surface. We'll change our element symbology for our surface. We'll use the terrain model, create from elements, and we'll select all of our elements that bound the cell. We'll change the feature type to breakline, or rather boundary, and the edge method to none. Next, we'll place an elevation on our cell center line. We'll do this by using the add feature. So we have to begin by locating the terrain model. We can locate it in either 2D or 3D, and then locating the element to add. We'll reset, and this time we'll be sure to use breakline. Next, we can set up stroking along these elements. We do that by going into the properties and changing the stroke value. In this case, I'll set it to 5 feet. Typically on the center line, we won't have this option because we've set a constant elevation. However, after the cell's placed, we'll have the option to change the stroke value along that line. We can also opt to change the stroke value along the arcs if we want. Typically 0.03 is a good place to start. So from here we can move to our 3D geometry and apply our linear template. I'll be using a template component that represents a curb and gutter, sidewalk, and end condition. This can be changed out at any time prior to placing the cell or once the cell's been placed. To make it easier, I'm going to turn off the reference of the 3D model in my 2D space. I'm going to select the curve return, accept the template, lock to start, lock to finish, and data point the direction of the cell. Before I do this, I want to change my symbology. So let's do that again. Select the curve return, accept the template, lock to start, lock to end, accept the direction, accept the sweep angle. And we'll move around the cell and apply the linear template in the same manner to each of the components. Last, we're going to put in place a surface template. In this case, we'll be using a pavement design with 3 layers. And we'll locate the terrain model, no boundary, accept the template, and data point to accept. We can now view our cell in 3D and see that it is in fact ready to place. Some other things we can do to dress up the cosmetics of the cell is we can set things as construction classes. As you've seen, we put one element in a construction class already. We can further this by getting rid of some of these constructions for our linear templates by hiding them in this construction class. So we'll just simply turn the constructions off, and move through our cell and add the elements to that construction class. Now we're ready to create the cell. Prior to creating the cell, it's a good idea to copy out your DGN file at this time. You may notice my cell now has a new name. That's because I made a copy of the original DGN before I create the cell. Now I'm ready to create the cell. I'll use the civil components, create civil cell. I'll give the civil cell a name. Let's call it BASICt. I'll locate the first reference. Remember, this is an element representing the secondary road center line that we expect will be in our design file where the cell is being placed. You'll see highlighted all the constrained elements off of this referenced element. Next, we'll select the horizontal line that represents the edge of pavement of the through road. This cell looks good. All my elements and components are constrained by one of these 2 lines. I'm going to reset to complete as I have no other optional elements. We'll explain optional elements later, and I'll accept the civil cell. We can further help ourselves in identifying our reference lines as we place the cell by setting up some names or naming conventions on those reference lines. If we drill into our civil standards in Project Explorer, into our civil cells, BASICt, we'll see our dependent and referenced elements. So if we go into properties of our BASICt cell, we can drill down in and we'll see our references. Within our references, we see the 2 components. The first reference we can name the secondary center line. The second reference we'll name through road EP. Now, when we place our civil cell, we should get prompts with those names. So let's just see what happens. Locate reference element, secondary center line, 1 of 2. So as you can see, the naming helps us locate the elements when we go to place the civil cell. Now my cell's ready. We can set up a DGN library with this cell by simply saving or renaming the cell as a DGN LIB and setting up our configuration. This concludes this lesson.